Hi everybody, we are starting our new chapter for transformations. So we're just going to do the general information on them first. So what is a transformation? It's basically changing something. So in geometry, we're going to change it by moving the position of it, changing the size of it, flipping it, turning it, rotating it, etc. I use transformers as an example because you go from, something and then you transform into something else, okay? I also use transformers as an example because it helps you remember notation, or at least in my opinion it does. So we all know, or if you don't know, I'm going to tell you that this is Optimus Prime. So the pre-image is always where you start. So he starts as a truck. That's the pre-image. And we're going to name him O for Optimus. And then he transforms into Optimus Prime, which is the image. And this little dash, that means prime. So the pre-image will always just be a letter. And then the image, what it turns into, will be that letter. And then we call this prime. So O, O prime, B, B prime, et cetera, et cetera, et cetera. All right. So you can consider transformations like a function. So I could easily just say, okay, change this so that this rule applies. So I'm saying add 3 to your x value and subtract 6 to your y value. So again, I'm starting with some coordinates, so let's say 2, 3, and I'm going to essentially substitute the values in. So 2 plus 3 is 5, 3 minus 6 is negative 3, boom. So t was 2, 3, and then when I transformed it following this rule, it became 5, negative 3. It could work the same with another coordinate, negative 8, negative 2. Again, you substitute those values in, and boom, you get a output, essentially. So a pre-image and an image, an input and an output. So another example, we can make up anything, really. So I could flip them. I could say do y first and then do x after. So this means from your pre-image, substitute that y value in here and substitute that x value in here. And when you do that, you get 6, negative 1. Again, substitute the y value in, substitute the x value in, and you get negative 4, negative 11. So the pre-image and then the image, A to A prime. In geometry, we have 4 transformations that we talk about. What I just showed you aren't necessarily any of them, because transformations can be anything. But these are specific transformations that we will discuss. So a translation, this is like sliding something. So let's say we start with a triangle. If I kind of just slide it along that line, boom, I translated it. So I slid it. Everything stayed the same. I just slid it over. Graphically, it's going to look something like this. So if you have this quadrilateral, you start, I know that this is my pre-image, again, because it doesn't have the prime, so I know I started there, and I slid it, so it went left and down. Oops, sorry, I'm going the wrong way. It went left and down to become this image, so all I would have to do is count the boxes, but again, it says right here, it went 7 units left and 3 units down, so I slid it to the left and down. A dilation changes the size of something, so it becomes bigger or smaller. The easiest example is to talk about your dilated pupil. So it dilates, it gets bigger and smaller. That's a dilation. Again, the pre-image would be the pink triangle here because it's the non-prime letters. And here I'm switching from negative 2 to negative 4, negative 4. 1 to negative 1, 2 to negative 2. So this is getting bigger. It's a dilation, definitely. And what you would call this is a scale factor. So it's being multiplied by some scale factor, and that scale factor would be 2. We're actually going to do an entire chapter on dilations later in the year. A reflection. So a reflection is going to be the flipped. And you just, think about a mirror, think about a lake. You have a reflection, right? There's symmetry through some sort of line. On a graph, it would look like this. Again, your pre-image is the non-prime letters. So this, what we're looking at, is a reflection over the x-axis. Because if I folded my paper along this line, this triangle would line up perfectly with that triangle. And a rotation. This is when you turn a figure. The easiest example I can give you is your phone. You rotate your phone all the time. You go from vertical to horizontal all the time. Okay. You're always rotating about a specific point. So in this case, like this is the center, because if you think about a rotation as a circle, you always need a center of a circle in order to rotate. We also always rotate counterclockwise or to the left. Think about Beyonce. To the left, always to the left. Pre-image, image, rotating to the left. Here's some new vocabulary that you're going to definitely need to know. Invariant, symmetry, isometry, and direct isometry. So invariant means not variant, so not changing. It doesn't change. In respects to what we're going to be doing, if we look at this reflection, This changes down to here. This point reflects down here. Anything on the line of reflection, like that point right there, for instance, is invariant. It stays where it is even through the transformation. So if ever there is a time that you have a transformation and something does not change, that's called invariant, if it just stayed the same. An isometry preserves distance and shape. When I say preserves distance, that means like the distance from AB is the same as the distance from A prime to B prime, or essentially the length or the size of the object. So it preserves distance and shape. So a translation, notice all my distances and my shape, it's still a triangle, and my distances are 3, 4, and 5, still my lengths. A reflection, same thing. It's going to be the same shape and size. Now, this on the left is called a direct isometry. On the right, this is an opposite isometry. The reason that the one on the left is a direct isometry is because not only does it preserve distance and shape, it also preserves orientation. And that's what we're going to talk about here. So notice, if you start at A and you go left, A, B, C, A prime, B prime, C prime. Now notice in this example, if you start again from A and you go A, B, C, if I go left, I go A, C prime, B prime. So I'm not going in the same order. That's what orientation is. It's oriented differently. And a reflection will never be a direct isometry because its orientation does not remain preserved. It is not invariant. The orientation changes. So again, translation, a rotation are direct isometries. A reflection is not. So if I ever ask you what doesn't preserve orientation, the answer is definitely reflection. Line symmetry, again, this is like the butterfly. I feel like everyone does this once in their life in an art class. You put a bunch of paint on one side of the paper, you flip it over, and boom, you got a beautiful butterfly. Okay, so with line symmetry, if you ever have a congruent object, what I mean by that is a regular object, so all sides congruent, you're going to have that amount of lines of symmetry. So in this hexagon here, I have 6 lines of symmetry. In this square, I have 4 lines of symmetry. This rectangle is not a regular object. It doesn't have 4 congruent sides, so it only has 2 lines of symmetry. And then point symmetry is also called rotational symmetry. If you start with an object and you turn it, and you turn it, and you turn it, how many turns do you make so that it looks the exact same? So if we took this triangle and turned it, I could turn it 3 different times where it would overlap precisely this exact same triangle. To find what that rotation would be, you divide. So 360 divided by 3, that would have been a rotation of 120 degrees. The easiest way to think about it is think about what distinguishing feature it has. This is called the order. So if we're talking about this fan rotating, it has blades, right? The fan blades. So it has 6 fan blades. I can count. That's 60 degrees. So it has a 60-degree rotational symmetry. Every 60 degrees it turns, it looks exactly like it did in the beginning. And that's it for your basics. So I hope you have a great day, and I will see you in class.